Looking good, guys. All right, today it will mostly be about wireless. All right, what we're doing here is radio. So this is going to be radio transmission issues that we're going to talk about a little bit, and just how we can get this to work in a networking context. Issue number one is radio. I'll just draw some nice radio waves here. So we got to have radio waves. We're going to transmit them, and then we're going to receive them. First thing to think about is antenna. There are two generally types of antennas you use. The first one, I'll just draw it like that. That's a lovely antenna, isn't it? A lovely antenna that broadcasts in all directions. An antenna that goes in all directions is called omnidirectional. All right? We have another type of antenna that is everything goes in one direction. I'm going to have it come back this way. So let's say everything goes in one direction. I guess I can draw it right here. You can have an antenna that looks like this. Okay? We're mostly interested here in the receiving antenna. So a directional antenna is going to be a dish. We call them a dish antenna because they look a lot like a dish. This dish is in the shape of a parabola. Okay? I don't know if you all remember parabola from your geometry class. I'm sure it was a very exciting class. And you probably remember things like a parabola has what's called a focus point. And when you did it in geometry, you wondered, what on earth am I learning a focus point for? It has nothing to do with drawing the graph, because this graph, I believe, was like x squared equals y or something. And you learned the focus point is about there. The focus point is very important to radio transmission because as a radio wave or anything travels in to the antenna, when it reflects off of the dish, it will always hit the focal point. So if I hit from this side, the dish is shaped such that it will always go down to that focal point. All right? So a dish antenna is directional because it is parabolic, and the antenna, if you notice on your dish network box, is right at that focus point. So that's a directional antenna. Now, great thing about a directional antenna is you point at the receiver or the sender. So I have one dish on one side and one dish on the other. That is also the disadvantage of it. So an omnidirectional antenna can be basically pointed anywhere. The big advantage of this one is the signal is concentrated. Concentrated signal, we'll say here. So all the signal coming off of this, just so you know, it works in reverse also. So as these come off, that's how we make a lovely, look at that. That is a nice looking antenna. So as the signals come off, they're concentrated, they're received and concentrated, so it's much better concentrated. And this one we'll just call it's diffused. One of the things we worry about is, if I think about my laptop out here, as the signal goes out, it's going to just be a little bit weaker as it gets to me. But it is more convenient. Can you imagine having your laptop or your cell phone with a dish antenna on it? That means you have to know where the access point is and you have to be able to point at it. No, we don't. That's why we use an omnidirectional antenna. So that's the main two types. And again, for the most part, you use an omnidirectional antenna. Speaking of going in all directions, generally speaking, wireless stinks. This should only be used when what we'll call closed media. Closed media is fiber, unshielded twisted pair, where the signal stays inside the cable. So we only use wireless when closed media is inconvenient or costly. Okay? Generally speaking, wireless is terrible. So we don't like wireless at all. And we only use it because people make us. All right? This will be a nice little diagram. I think I can fit this all down here. So, propagation problems, or propagation effects, I guess we could say, are, and we'll just call them considerable, if I can spell this right, considerable. Okay? Propagation issues are considerable in wireless. So let's think about this. I will draw my access point here. That's a lovely access point. And we understand it's sending out signals. All right? The first issue is what we call the inverse square law of attenuation, and I think I talked about this before. We'll just call this rapid attenuation. Attenuation. A rapid attenuation, I think I need to write these a little bigger, sorry, with distance. So as we go out further from, my goodness, rapid attenuation with distance. The further you get from the antenna or the sender, the weaker the signal will be. So we understand, hopefully, the signal is being spread out so much that it's much, much weaker, or the amount that gets to us is much weaker when it gets to us. So we've talked about that, just in case you're interested. If, for example, you're 10 feet away and you go out to 20 feet away, the signal actually goes down. They call this the inverse square law. We went twice as far away, but the signal is 4 times weaker. So even though you're twice the distance, you divide your signal strength by 4. So it's really, really terrible. Attenuation will kill you. All right, next issue. If we have a wall, for example, make a lovely wall here. That doesn't look like very much of a wall. And we have our computer behind the wall, we can have what's called a shadow zone. So this might block the signals. And again, under other closed media, we just have to run a cable to where we need it to. In this case, we have to be careful about where we're putting our broadcast and receiving stations. Because it wouldn't really be able to get a signal from the access point and also wouldn't be able to broadcast to it. Okay? So this would be a blocking object, and that's going to give us a shadow zone. The third issue is there's lots of interference. This is an open media, plus it's radio waves. So there's other stations. So other stations might be broadcasting using the same channels, and might just be general, we'll just call it background. There is a lot more background radio interference than there is sort of electric interference. Y'all remember when we did unshielded twisted pair, most of our interference was crosstalk, so interference from our own cable. With wireless, we're going to actually get stuff coming out of the background. All right, next one up is what we call, this is a really fun one. We have an issue where, oh, and I got my signal right here. A signal can bounce off of things, and that means it can bounce off and bounce back. So we have this problem where there might be one part of the signal that hits me directly, and another part of the signal that hits me indirectly. And since the one arrives later than the other, it can interfere with the original or the stronger first signal. Okay? This here is called, and I can hardly write now, we'll just put multipath. Multipath, if I can spell that. Multipath, my goodness. And I can't even erase those. Multipath. So that's number 4, multipath. So this late arriving signal will interfere with the faster sooner arriving signal. If you've ever watched on TV, and you don't even do this anymore, in the old days of TV, this would give you what's called a ghost effect, where you'd see like a picture of a person, and then just a little ways over, you'd see sort of a faint picture of the person. That's from the signals that arrived later. So multipath interference, another big issue with wireless.